Okay, how many of you guys are Redshift users? Okay, most of them. How many of you guys are currently evaluating Redshift? Okay, few. All right, my name is Debu Panda. I'm a product manager with Amazon Redshift. And today I'm going to take you through a journey how you can build a scalable analytics platform with Amazon Redshift. I have been talking to a lot of customers today during several EBC sessions and also right after my AWS theater session. And many of these organizations are in different phases of their migration to the cloud. Many of them are already in AWS, and some of them are evaluating to move to the cloud. And so they have a lot of on-premises data warehouses. They are still running in their legacy data warehouses, and then they are trying to migrate this to AWS and Amazon Redshift to build a scalable analytic platform. And as they migrate to the cloud, so they evaluate a lot of other opportunities that they have. As we hear from more and more customers, data warehousing and analytics platform are no longer a luxury. It's required for survival for most of the organization. They want a scalable analytic platform to remain competitive, to become customer-centric. And when we talk to them, what we hear from them is the actual change, analytics requirements are changing. And what is happening is there is a lot of event data that is coming in to their analytic platform. As you see, like if you go to San Francisco airport, you know that the toilet, they have awesome, bad, and okay, like there are different buttons. And you click in there to basically do a survey how is the bathroom is. So similar metrics are being collected from different devices, and all those events data are coming in. And many of the organizations do not want to analyze those data in silos, but they want to join their data in the data warehouse with the operational analytics data that is coming into their analytics platform. And they want to get end-to-end insight of their data. And as they do that, they have a lot of challenges. And as you know, we call this like the 3V problem. What means basically the volume of the data is growing because you get a lot of different kind of data. There are some research that tells that in the last 2 years, the amount of data that organizations have generated has doubled the size of the amount of the data that they were generated previous 2 years, okay, or in our lifetime. And in the 3V problem, not only volume of the data, there are different variety of data that's coming in. Those are not just relational data. And the third dimension of 3V is the velocity of the data. It is coming in a very rapid pace. And the traditional data warehouses, what you do is that ETL once a day. And those kind of requirements are not being met, and the traditional databases cannot support the variety of data like in the open source format like Parquet, Avro, or JSON. And when you have all this kind of data, you want to generate insight from this data. And data warehouses like Amazon Redshift had democratized the access of the data to multiple personas. Like no longer the BI guys just run the dashboard on your data warehouses. We have different personas like the developers, the business analysts, the data analysts, the data scientists. all those different personas now try to access the data. And when you have large amount of users who are trying to access the data, you want to make sure that you have the concurrency and the performance and the scalability that you need in your analytics platform. And the other thing is that there are different kind of analytics need your organization have. It's not just data warehouses. Customers have different other tools like EMR or other tools like Athena. They want to run different kind of ad hoc analysis on some of this data. So they have different requirements using the same kind of data. And then as you move to the cloud and you make this data available to large number of users, you run into the security and governance aspect of those data. And as you grow with more amount of data, you always care about the money or the cost. So you want to select a platform that is not costly and flexible enough for you. So what they are doing is customers are moving to data lake architectures to take benefits or meet the requirements they have. And Redshift, Amazon Redshift, with the Amazon Redshift Spectrum, allows you to extend your queries from Amazon Redshift to the Amazon AWS S3 data lake. So what Amazon Redshift allows you to do, what we call fondly, is that lake house approach. What I mean is that, so if you see here that you can have one foot in the Redshift in the data warehouse and the other foot in the data lake. So you can make queries or run queries in Amazon Redshift that not only queries the data in the data warehouse, but you can join the data that is sitting in your Amazon S3 data lake running in different formats like Avro or JSON or Parquet. So Amazon Redshift is the most popular data warehouse. We have tens of thousands of customers who use Amazon Redshift. And if you look at the amount of customers that we have customers across all the different business segments. You take it whether for healthcare, whether you look at manufacturing, financial, all different segments of customers use Amazon Redshift in a very meaningful way. And there are several customers that they are telling their stories in the reInvent. So in the next 3 days, you will hear from customers like Yelp, Comcast, Workday, Duolingo. There are a lot of customers who are presenting about their implementation of Amazon Redshift in this reInvent. And we have the largest customer of the data warehouse Redshift is Amazon.com. They are also telling their story in Amazon Redshift. So please attend some of the sessions. So as I was telling, there are tens of thousands of customers are using Amazon Redshift. And there are several benefits for using Amazon Redshift as your analytic platform. The first and foremost thing is that it is natively integrated. It was born in Amazon AWS, and it is natively integrated with AWS and Amazon S3 data lake. So it is integrated with all other services and tools within Amazon data lake. Like if you take tools like Glue, the tools like Amazon QuickSight, AWS Lake Formation, all these tools are natively integrated with Amazon Redshift. And it inherits all the security and all other things from AWS. The second thing that we are announcing here is that we have the best performance. So you will hear more about, and if you are going to go to a performance presentation, that we have our performance is 3x performance than any other cloud data warehouse. I'm not going to name it, but you can do. We have published the TPC DS benchmark. We have published the scripts. You can just take it and run it yourself. And we are the cheapest data house. We are 75% less than any other data warehouse. You can start very low with 25 cents per an hour and go up to whatever the amount you can go. And in the last year, we introduced something called concurrency scaling. I'm going to discuss more on that topic a little bit later. So concurrency scaling actually allows you to scale Redshift in a very serialized way, and with kind of virtually unlimited, it provides unlimited elasticity or linear scaling. And Redshift is most secure and compliant. It provides all the AWS grade security. It is integrated with, you can run Amazon Redshift in your own VPC. It provides encryption with AWS KMS and all the different compliance certifications like HIPAA or SOC or PCI. It covers all those compliance certification. Many customers think Amazon Redshift is very, very complex to manage because it was invented 7 years back. But Amazon Redshift is a fully managed service. You do not have to do anything except provisioning your cluster or the data warehouses and managing your workload. And the rest of the things like taking backup, patching, all those things are taken care by AWS. And we provide 99.9% of SLA with Amazon Redshift. So this is a quick architecture for Amazon Redshift. So this kind of gives you, the way the actual data lake architecture works. So if you look at the leader node, is a node where all the queries come to, and then we have different compute nodes that actually executes all the queries in parallel. We use something called massively parallel processing, and we have a columnar architecture. And then if you are running queries that goes to S3 data lake, then we have the spectrum layer that actually runs your queries and sends your data back to Redshift. So I'm going to show some demos on some of these capabilities later on. All right, so there are different use cases. We hear every day different kind of use cases that customers are using Amazon Redshift for. But there are 3 key use cases that we hear from customers. First is modernizing their data warehouses. Customers have their data warehouses running on either Netezza or Vertica or Oracle Exadata, and they want to migrate to cloud. And that is our most popular use case, is that customers move their on-premises data warehouse to the cloud, and that's what we call modern data warehousing. And the second kind of use case that we see a lot of customers are the operational analytics use case. So what do I mean by operational analytics use case is that customers generate a lot of real-time streaming data. And typically, this kind of analytics is done by Elasticsearch or tools like Splunk. But many customers, they want to join this data with their business data. And that's when the typical analytics, operational analytics tools cannot solve the use case of joining your data in the data warehouse with the real-time analytics data. And a lot of customers are using Amazon Redshift for joining their operational analytics data with their business data. That's called operational analytics data. And this is the third use case is we see a lot of growth customers are using is the data lake integration. Customers have their data in Amazon Redshift, but they want to join the data in the S3 data lake without having to load the data. Because when you load your data, you have to scale your cluster, you have to pay more money because your size grows. But when you data is in there in S3, you only, and then you are using for your data lake analytics, then you just pay for the data that is scanned when you are doing a query. So what's new with Amazon Redshift? In the last 18 months, you wouldn't believe, we have added more than 200 features. So whether you guys read the what's new or not, in the last week, we released 7 or 8 big features. And so all the slides will be available to you, so you can read this too. But we have added tons of slides, features in the last 18 months. So these are, and stay tuned. So I am not announcing a lot of new features, but there will be a lot of new features that will be announced tomorrow towards the end of the week. So you'll see a lot of new features coming in also beside this what I have. So when we look at the different features, as customers want to build their analytics platform, we look at 4 or 5 different themes or dimensions that we want to add a feature for. First thing is that people want to build a scalable platform, and basically they want their query to be executed within like milliseconds or microseconds. So we spend a lot of time on improving the performance of Amazon Redshift. The second one is that when you have large cluster, you are managing a large analytic platform, you do not want it to be very complex. You want it to be simple. So we spend a lot of time and energy to improve the ease of use for Amazon Redshift. Then security is a table stake for when you are running in the cloud, your data warehouse or analytic platforms. So the security aspects come for free because security cannot be a luxury in the cloud. And whatever the security feature we add, it comes as a free. There is no different addition for security with Amazon Redshift. And the other dimension that we are adding a lot, focusing a lot, is the data lake integration. Many customers are extending their analytic platform to data lake, so we are adding a lot of capability in data lake. So let's first start with how Amazon Redshift is simple to manage. So if you look at the first thing is that Amazon Redshift is fully managed. It is very easy to provision a cluster or a data warehouse, and then it's managed, and we provide 99.9 SLA. You do not have to do anything for managing your Redshift cluster. Then in the previous generation of Redshift, as an administrator, you have to manage some workload. So you have to create, there are several operations that users had to do, like vacuuming, analyzing, sort key, disk key. So we have added a lot of capability that I'm going to cover in the upcoming slides that makes Redshift easier to manage for you guys. And then when you have a scalable platform, you want to customize to your need, because you cannot just make it simple, but you do not provide any kind of customization to the user. So we provide a lot of capability for customization. So with that, what I'm going to do is that show you some of the cool capability that we have added. So first I'm going to show is the new Amazon Redshift console. We launched about 2 weeks back. How many of you guys have tried the new console? All right, few of you guys have tried the new console. So what we have done is that we have heard from a lot of feedback from you guys and modernize it and kind of we given capability to gain insight, better insight to the health and performance of all your clusters in the console, as well as we kind of help you share the query editor with your non-DBA or non-admin users with a separate URL, although it is integrated to the AWS console. So what I'm going to do is that instead of going through the slide, I'll just show you a live demo. So let me. All right, so let me switch here. Okay, so this is the new Amazon Redshift console. That this kind of gives you a quick overview of all your cluster in your account, how they are doing, whether all of them are available or are maintenance, how many number of nodes you have, whether you have alarms, so you get all the CloudWatch alarms there, all the events for your clusters, some key performance metrics like your number of queries or CPU utilization or the database connections, and you can change it to last 12 hours or 24 hours. And similarly, we have some query metrics in here. So what you can do is that you can actually want to focus on a specific cluster, you can focus on that specific cluster here too. So I selected only Redshift cluster 1, so that kind of gives you focusing on, and then one can navigate to that cluster. But before I do that, because many customers think that creation of a cluster or the Redshifts is very, very difficult. So what I'm going to do is that I'm going to show you quickly how easy it is to use to the console to create a cluster. So as you can see, let me expand this one. So the only parameter you need to specify is the password. If you are creating a default just for trial. So the only thing is that you just by default you selected a DC2 node, which is available for free for 2 weeks. Then you can change your number of nodes that you want to change. And as you can see here, the number of nodes, whenever I change, actually shows me how much data compressed data storage I have, or how much, and also how much money I'm going to spend. And I can just change my name of the cluster, and then I have to select my password. Okay? So I'll just, okay. All right, so and the all other parameters are all optional. So if you want to select your VPC or configuration, all this can be selected, but the only thing that you need to provide is a password and rest it. So as you see here, my cluster is being created, and then here you go. And in 2 minutes, the cluster will be available. The other complexity that customers think is that it is very, very difficult to write some queries and load some data into Redshift, because Redshift do not provide some native tools, and you have to use third-party tools, and you have to download your JDBC driver and all kind of thing. So as I told you earlier, that we have the query editor, which is integrated in here, and the query editor actually lets you create your table, browse your table, show a preview of the data. So for example, here I have the information schema. I can go to my public schema, and that shows all my different tables that I have. Then I can actually go and you do preview some data for that table. as you can see here, the data, I can see the table definition. So all those things you can easily browse through. And the other thing that you can actually run queries or a statement, like for example, I can run this create table. I think I created in my last demo. So the table is already there, so it's going to fail, but I can just try showing you. Like for example, I can just do a create table, and that is going to create the table. And similarly, you can use the copy command to run load. So I can just do a run of copy command, and that is going to load data into my there. So we recommend you to use copy command for bringing in data, large amount of data into Amazon Redshift, because copy command, when you use copy command, all compute node can load the data parallelly. That's some of the benefits that you get from having a massively parallel system. So then what I want to do is that I want to run some query, for example. Okay? So let's run this simple query. I can, excuse me. So this query is running. So so you can run the query, and what we can do is that we actually allow you to do basic visual analysis within the console too. So let's I think the Wi-Fi is a little bit slow here. Let me drink some. Okay, so yeah, actually Wi-Fi is not that great from here. So when you actually run the query, after that you will, the first thing is that this query actually running against also Spectrum. That I wanted to show you, that as a part of our data lake architecture while the query is running, so I can show you that the kiosk is nothing but a schema, that an external schema that I have created by using, by creating an external catalog. So I want to just show you that how you can see this data too here. So I've created an external schema, and then I have created an external table that uses the data there located in S3, a bucket. So I'm using this data. So when I make a query, I run a query, actually it goes and run the data, joining the data from my data warehouse as well as S3. Still running, so okay, let me just run a very simple query in here. So that, let's say I do select star from listing that I already Okay, while it's running, basically, let me just go back and then show you some other capability. So I think this is a little bit running slow in here for some reason. If my other query finished, okay, so is that my, here, okay. Yeah, so if you see this data, actually it's actually combined the data from my Amazon table, Redshift table. So as I can show you here, so I have my two schema I'm joining, the kiosk cell and public event. Public event is a table in Amazon Redshift, and kiosk cells is the table, the external table that I created in Amazon S3 based database on Amazon S3 data. So this is the data that I got. And what we provide is the ability to show some other capability, like you want to export this data and share with some of your friends like CSV or text for further analysis. You can do that. You can visualize this data within here, because what people tell is that, picture is worth 1,000 words. So you can do like quickly show you this kind of, okay, this the event ID 289 has the probably maximum number of the event that I have. And then similarly, we actually show you the execution plan in context. So you can see here that actually the query actually goes to Amazon S3 in here. So that's the soft query, this one. And then this also gives you the actual exclamation and receive some problems in the query. So when you click on here, actually that will show you some in-context information about how to tune your query. This kind of gives you a quick way to run away your queries, whether the query is within, that query is only for your native Redshift tables, or the query expands to your data lake within the query console. And as you can see here, this user actually has is a different, I'm using a different URL, and this URL you can provide to user, and you can just give them the Redshift query editor and read-only privilege on your Redshift cluster. In that way, they only have access to the query editor, they do not have access to the full AWS console. All right, so let me now switch back to my presentation. So coming back, like in the last several months, we have made several changes in Amazon Redshift that make it very, very simple to use. You have to analyze your table, like prior to this, you have to analyze your table because the query planner uses the statistics in the table to basically optimize your query. And if you have a large table or any table you have, if there is no statistics there or you haven't analyzed the table, then you cannot use the right query plan. And what we have done is that we have made it automatic. Earlier, people have to do it manually. Now, Amazon Redshift finds time when like your clusters are not being used, and then it automatically analyze your table. Similarly, many customers, like whenever you remove or delete a lot of rows from your table, you have like fragmentation in your table, and there are basically space that needs to be reclaimed. And earlier, customers have to run the vacuum command to reclaim that space, and we have automated that. Now, Amazon Redshift automatically vacuums and reclaim your space, so you do not have to do that. Similarly, we have something called auto table sort. So we automatically look at your order, your query, your actually workload, and automatically sort your table based on the queries that is being run in your Amazon Redshift. So we are using machine learning to analyze all your query pattern and automatically organizing your table. Similarly, what we have done is that we have had support for auto distribution key. Or like what we are doing is that we are right now giving you also advisor recommendation. So if you have not defined the dist key or sort key, then we actually give you recommendation that, okay, looking at your query pattern, that, okay, this is the right way to have your distribution key. And actually we give you in the alter command, table command, to that you can take and run your command to change your sort key or dist key. So we have giving a lot of recommendations and automation, and in future we are going to automate that too. You do not have to manage anything by yourself. So this is like we discussed about automatic table sort, so we automatically do this for you. We have now support for stored procedures since April of this year. So if you are using, like in your older data warehouses, stored procedures for ELT or any other processing, now we have support for stored procedure. And if you are trying to bring in or migrate from a legacy data warehouses to Amazon Redshift, you can bring in that business logic into Amazon Redshift. And our tools like SCT schema conversion tool and database migration service, those help you also convert the stored procedures. So now let's look at this scalability and performance improvement that we have done in the last 1 year to help you build a scalable platform, analytics platform. So we have done a lot of changes. The first thing, let's look at some of the capability. Like you want to scale your data, all your data. And we allow, as I showed you, the data lake, the data lake demo, that we allow you to query your data at any scale using Amazon Redshift with Amazon Redshift Spectrum. And you do not have to load this data. All this data that is in your Parquet, JSON, or other format, you do not have to load this data in Amazon Redshift or like other data warehouses. And what we do is that we allow you to query the data using the Amazon Redshift. And as you saw a quick demo of that, and many customers are actually building different kind of dashboards using same kind of data. So I'm going to just quickly show you a dashboard that I built. So I'm not going to do a demo because the performance is not great here from the Wi-Fi performance. But this is a dashboard that I built that leverages the data in Redshift as well as in S3 data lake. Let me describe the use case here. Think about a company called Amazon Spectrum Store, okay? And the Spectrum stores sells their merchandise in like their warehouses as well as using the different kiosks located in across different cities. And what we do is that, let's say, all the data that is stored in Redshift is coming from all the warehouse data. So this is, again, a fictitious store. And all the data that is coming from the kiosks are coming to the data lake directly using in Parquet format. And this dashboard actually shows you how you can combine the data by getting the total sales and the total quantity sold. Those are the union of the data coming from other S3 data lake and from Amazon Redshift. And on the bottom, you see these two different scatter plot. Those are actually coming from the two different sources. So one going directly to S3, other one going directly to Amazon Redshift. All right, so next is when you build your scalable platform, you want elasticity. So last year again, we announced in Amazon Redshift, but there was GA sometime the Q1. So we support now Elastic Resize. So Elastic Resize is nothing but adding nodes into the same cluster. So you do not copy this to another cluster like the classic Resize. And the data gets available within few minutes, not hours. And many customers that we talk to, it's a very, very popular feature. Many customers use Elastic Resize to like, for example, on the daytime. Many customers, when they have large number of users coming from Monday to Thursday, they at 9 a.m. they increase the number of nodes in their cluster to 4, or let's say for example, and during evening time they take it down to 2. So they scale up and scale down based on their need. Many customers, they do, at the month-end processing, they want more processing power for their data load or report generation, so they add some more nodes by using Elastic Resize. So the main interesting thing that what we have done is that many customers actually use this as manually. So, so what we have done is that a week back, we actually now provide ability to schedule it yourself. You do not have to depend on a third-party tool or manually resize in the morning and the evening. So now you can schedule up and down events, any kind of resize operations, either in a day, on a one-time, or in a recurring manner, either using the AWS CLI or API, or using the console. So let me just quickly show you. I'm not going to run, but what I'm going to show you that how easy it is to do that. Okay, so this is the console that I have. Let me go to, so I have to go to a cluster. So let me go to my Redshift cluster 3 that I created at the time, and I want to resize it. So you can just do click and resize, and then I select Elastic Resize. My number of nodes during the resize will be 4 because I had 2, and what I can do is that, sorry, I had 4, so I can do it to 8, or I can do it to 2, or I can do at a later time, or recurring events. So what I can do is that I can scale up and scale down. So I just specify number of nodes to 8, that is scale up, and I can do, again, a scale down at a given point of time. So I can do this kind of operations based on my requirements, and it can do in a daily, monthly, whatever. You also provide cron style syntax if you prefer that. If you are a developer or builder by heart and you want to use the cron type syntax, you can do that. So this kind of gives you ability to schedule your resize operation by using other API or the console. So the many customers, they do not have predictable number of users. They see occasional burst, like, okay, on Monday morning, sometime I have like a lot of users come, and at 9:30, my number of queries coming to Amazon Redshift goes up. It doesn't happen every Monday, but some Mondays happen. And sometime it happens on Friday or some other day. So they do not want to increase the number of cluster to satisfy those kind of burst requirement. So what we have ability something called concurrency scaling. So what concurrency scaling is, if you enable concurrency scaling, it will and based on your configuration, and like for example, what is the query depth size you want to see, and based on that, it will automatically add new cluster and serve the queries, so that your users will not see any kind of performance degradation. So it can serve a lot more number of users, even if you have. And by the time the number of concurrent queries has gone down, the clusters will go away. And we just count by second. And it is free for every customer, 60 minutes in every 24 hours. And you can accumulate that up to 30 hours in a month. So what you have seen that most of the customers who have enabled concurrency scaling, they use it for free. 97% of the customer do not pay a penny for using concurrency scaling. So if you see that kind of bursty workload in your environment, we recommend you to use concurrency scaling. And what we have seen is that this kind of gives you a linear concurrency or linear scalability to customers. Okay. Then many customers, I think this is again one of the ease of use capability that we have added, is that many customers, they have to, earlier they had to manage, the queues and how much memory you want to allocate to the queue. So we actually added capability called Auto WLM. So Auto WLM will automatically look at your load and manage your workload. You do not have to do anything of your own. And many customers wanted intervention, the way Auto WLM work. So they wanted, for example, I do not want my BI users to be affected at all. I want to give them the highest priority. I want to throttle my ETL a little bit if something is happening at the same time you are using. I do not want to give highest priority to my data science user because they always take unload a lot of data from Amazon Redshift. So we added something called query priority that become generally available about 2-3 weeks back. So that kind of help you, use Auto WLM in conjunction to control who you want to give higher priority. And kind of this gives control. And in that way, you do not have to manage your queue yourself, but at the same time, if you have different user segment and different user persona and give them one user priority over the other, then you can create a queue and give them higher priority. All right. We have done a lot of changes in Amazon Redshift. So now, if you take a workload that was running, if you have not made any configuration changes, and if you had done a POC or run something 6 months back, and you now start a POC with Amazon Redshift, the out of the box performance is 2 times what we had 6 months back. And how did we achieve it? So I think there is a blog that is going to be out tomorrow that kind of tells you what are the different kind of performance improvement we did it ourselves in Amazon Redshift that help us make this. First thing was this AZ64 encoding that we added. So it is not yet default, but we're going to make that the default encoding that I'm going to discuss a little bit more on AZ64 encoding. Then we have actually improved their Bloom filters for the co-located queries. So what we do is that whenever we use 2 large tables to join those things, now the performance is much better because of the improvement that we had. Similarly, we enhance the query planner to take benefit of the new CPU and networking that we have now. And then we are also leveraging some of the hyperlog statistics that we generate. And then let's look at some of these capability that we have. AZ64 is a new compression encoding that we added recently. And it is a very high compression ratio encoding that this is like a TPC DS like benchmark we did with the 30 terabyte data that shows that AZ64 saves 60 to 70% storage on than raw and about 35% storage than LZO. But if you look at the performance, it actually improves the performance by 20 to 30% for raw, 40% than LZO encoding, and it is comparable to GSTD, but actually the performance is 75% better than GSTD. So we actually recommend you to use this new encoding, and this new encoding is primarily for the data types like either a numeric data type or timestamp. And when you are creating your table or you're altering your table, you can just specify the encoding for your column. All right, so this the second thing that we announced, last week is that materialized views. So many of our customers, they have their dashboards. They run in their existing data warehouse, or what they do is they do only ETL once a day. And the dashboard actually goes to that last daily data, or maybe last, which was refreshed against last was refreshed 8 hours back. And when you try to join multiple tables and try to build a dashboard, sometimes it doesn't perform. So what customers have been asking is that ability to have materialized view. So we have now preview support for materialized view. It is available for everyone. So you can go to the maintenance track and select the public preview. And with this new release, we can create your materialized view, and we provide ability to either full refresh or incrementally refresh. And what you've seen is that many customers who tried this in their environment, they have seen significant performance benefit for using their dashboards. Okay. Then, how many of you guys use kind of spatial data, like any kind of geometric data? Few? Okay, so you are using some kind of workaround now. All right, so we actually, this feature is now generally available. You can, the spatial processing was available last week, and it's a new type of data type that we added called geometry type. And we now support different shapes like multi-point, multi-line string, multi-polygon, and now we support 40 plus SQL functions to support this. And this will help you, combine the data, the business data with your spatial data, and you can bring in all the spatial data together. So what I'm going to do is that actually I'm a brave person. I'm going to use a live demo instead of. So let's see whether my performance for this one is better. Okay, let's see. Let me run this. So, all right. So let me switch. So this is a dashboard that we have built. This kind of shows you, the Airbnb data for city of Berlin. So all these different accommodations that is available, not available, all this data are is now we are showing in there. So what I'm going to show you is, this is a cool demo, but main interesting thing is that the SQL that you can run. So when I click on accommodations, do you see the SQL on the bottom? So actually that uses spatial processing. If you look at use different types, different functions they're using. Similarly, let me just look at the heat map. So you see this kind of how the heat maps, where the actual hotspot for Airbnb locations are. I can drill down there further, and when I drill down, you'll see the different SQL changing. And similarly, I can look at my different zip codes where these are there. And all this is now available to you guys, so you can use it now. This is not a preview feature. This became generally available last week. With that, so I'm going to switch back again. Okay, so let's summarize. So first, we have added 200 plus innovative features in the last 18 months. Amazon Redshift is the most popular data warehouse that is used by tens of thousands of customers. We have simplified several admin operations for administrator like you. Then you can scale your load by using either concurrency scaling or using Elastic Resize. And the out-of-box performance for Amazon Redshift is now 2x faster than what we had last 6 months. With that, here are some related sessions that we have that I recommend you to attend, like Andy Jassy says, the keynote tomorrow, that you'll hear more about different than enhancement or the new features that we are adding. Then there are a couple of what's new session that goes more details into all the new features that we are announcing this week. All right, so there is, you can learn with AWS training and certification that is available here. And thank you very much for joining this session.